Hello all, this is Vishnu. From today onwards, I'm going to discuss about C programming tutorials from very scratch, means 0 to hero level. Okay, so today we are discussing our first lecture. Before going to programming concept, we should know about some background process, that is prerequisites. These are prerequisites to any programming language. These are prerequisites to any programming language. Okay, so what is today's agenda? In today's class, we are going to discuss about what is programming language, need of programming language, what is compiler, what is BIOS, what is secondary memory means ROM, what is primary memory means RAM, what is application, what is process, OS, CPU, firmware versus software. So all these concepts we are going to cover in today's concept. Clear? Okay. Now we are going to discuss about what is programming language. What is programming language? You know what is programming language. And next we'll discuss what is need of programming language and what is compiler. So first we'll discuss what is programming language. See here. Question is, what is programming language? First of all, tell me what is language. You know what is language. It is a medium, just like Telugu language, English language, Hindi language. Why we use the language? We use the language to communicate with people. Similarly, we use the programming language to communicate with the system. So these programming languages are treated as high level languages. So what is programming language? It's a high level language. So what is programming language? It is a high level language. It is a high level language which is used to communicate with the system. Communicate with the system. Or can say machine. Or better, even better, you can say CPU. To communicate with the CPU. Question. Sir, why to communicate with the system? Why to communicate with the system or CPU? How to justify this question? Why to communicate with CPU? Okay. I will ask you some question. Tell me what is the answer for 5 plus 5? You know very well, 10. What is the answer for 25 into 25? You may know this answer. That is 625. Answer is 625. Again, I am asking question. What is the answer for 625 into 625? You may take some time to calculate what is 625 into 625. You may take some time. So what is better approach here? Better to use calculator. Means you are using calculator means you are using the system, right? How much time the calculator or mission will take to calculate this 625 into 625? How much time it will take to calculate 625 into 625? It will take just a fraction of seconds, right? It will take just fraction of seconds. Not only 625 into 625, even 1000 times harder question, means tougher question if I ask, the system will take fraction of seconds only. 625 into 625 is easy question. If I ask 1000 times tougher question than 625 into 625, then it will take even fraction of seconds only. Okay, na? So what is the answer for second question? Why to communicate with the CPU? Answer is to perform complex tasks. To perform complex tasks. Okay. And third question is programming language understandable by the machine? Is programming language understandable by the machine or CPU? Tell me the answer. Answer is no. CPU understands only binary language. CPU understands only binary language, that is machine language. Machine language means zeros and ones. Like 000, 111, 000. This is the machine language. So CPU understands only zeros and ones. Then how to communicate with the system? If CPU understands only zeros and ones, then how to communicate with the system? See here. Why to communicate with the system means you already know that to perform some tasks. Okay. So here I'm writing some small program. Example. I'm writing some program here. Hash include stdio.h int main function, and a small program I'm writing int x equal to 10 comma y equal to 20 semicolon, int sum equal to x plus y, printf percentage d comma sum. Okay. And so many students don't know about some concepts, some theory concepts. That is, I'm asking question. See here, even though if you are a good programmer, for you also I'm asking a question. That is, I'm writing int x equal to 10, y equal to 20. Who is going to assign 10 value into x? Means if you are writing x equal to 10, y equal to 20 means somebody has to assign this 10 value into x. Somebody has to assign this 20 value into y. Here you are writing int sum equal to x plus y. So somebody has to add x plus y. Who is doing all these operations? Any answers? Who is doing all these operations means CPU. Means CPU only executing all the statements. How many statements I wrote? 3 statements. But I already told CPU understand this high level language. This C language is middle level language, of course, but CPU understands only binary language. Yes or no? So can I directly submit this program to the CPU? Can I directly submit this program to the CPU? No. CPU will not understand this program because it is a middle level language or high level language, but CPU understands only binary language. But what to do? So what to do means you have to give this high level language to the mediator first. So who is that mediator? Compiler. So I'm going to give this to compiler. Before giving your program to the CPU, submit it to the compiler. So I'm giving my program to compiler. What compiler will do? It's a software. It converts this high level language to binary language, means into the application executable file. This executable file is in binary format, zeros and ones. Okay. Now, can I give this executable file to the CPU? Yes. And this executable file is also called as application. You are using so many applications, right? Instagram, WhatsApp, Facebook, you are using so many applications. All that applications are technically called as executable files. You can say your applications as executable file. Your WhatsApp is a executable file. Your Facebook, Instagram, whatever it is, everything is treated as executable files only. Now, can I give it executable file to the CPU? How to give it? CPU, take this executable file like that you are going to give. See, here is some mechanism. You are directly not submitting this executable file to the CPU. There is some mechanism here. What is that mechanism? You have to load this executable file into RAM first. So what you have to do? First, you have to load this executable file into RAM. So how to load this executable file into RAM? By writing /a.out. This .exe is also treated as a.out. A.out, executable file, application, everything is same. So by writing /a.out, this a.out will be loaded into RAM. So now tell me, this a.out is in which format? Binary format. Okay. So now this is loaded into RAM. Now tell me, this RAM ka information is in which format? Binary format. What it contains? It contains same information. This information only available here. But in which format? Binary format. Who converted this? Compiler converted this from high level to machine level. Why to convert? Why, sir, compiler converts like that? Because this CPU understands only binary language. Now the CPU will fetch data from RAM and execute line by line. What is the responsibility of CPU? It will fetch the instructions and decode the instruction and execute the instructions. Fetching, decoding, executing. Fetching, decoding, executing. This is the responsibility of CPU. So now what happens exactly? See here. What CPU going to fetch first? What is the first instruction here? Of course, it is in binary format. See here, what is the first instruction here? The first instruction is x equal to 10 and y equal to 20. So it will fetch x equal to 10, y equal to 20. It means CPU will fetch x equal to 10 and y equal to 20, and it will assign 10 value into x and 20 value into y. Next, it will fetch sum equal to x plus y, and it will add x plus y. Who will add x plus y? CPU. What is the result for x plus y? 10 plus 20, which is 30. That is assigned in sum. Who will assign in sum? CPU only. So what is sum value? 30. So CPU executing all the instructions. Okay, now don't confuse what is the meaning of execution. Execution meaning means you wrote here, see here in the program, you wrote here x equal to 10. If CPU assign this 10 value into x, then this is the meaning of CPU executed this statement. When CPU add x plus y, then it is the meaning of CPU executed x plus y. If CPU not add x plus y, then CPU not executed this instruction. Getting my point? Yes or no? So what I did here, last and final, first I have to write the program and I have to give it to the CPU actually, but CPU not understand this high level language. That's why I'm submitted this to the compiler. So compiler is a software which converts high level to low level into machine understandable format. So now this is in binary format. Now I want to execute this. Who will execute? CPU will execute. So now you have to load it into the RAM, because CPU always executes the applications by fetching from the RAM only. Okay, now so this a.out is treated as what? This a.out is treated as application. When this application is loaded into the RAM, then this application is treated as process. Very simple. Don't confuse between what is application and process. If the application is loaded into the RAM, if application is active in RAM, then this is treated as process. If it is in secondary memory only, see, it is loading from secondary memory into RAM. We have a clear diagram. Don't worry, I will discuss this clearly because I have a clear diagram. Just brief explanation I am giving. You should know from this, okay, we are not going to submit your program directly to the CPU. We need compiler, because compiler need to convert from high level language to low level language. And after compiler converting it into binary, you need to load this binary, means application, into the RAM. Yes or no? So when the application loaded into the RAM, that application technically treated as process if the application is active in RAM. Now CPU will fetch line by line from the RAM and execute all the instructions step by step. I hope this much clear, right? Okay. Next, see here. See this diagram. Consider you bought a new system. This is your system. You bought your new system because you want to practice C programming tutorials. That's why you bought this new system. Okay, now if you bought your new system, is there any applications in your device? No, maybe some default applications may be present in your device. Yes or no? Okay, now see this. See this diagram. What is this? This is a monitor. This is a monitor. What is this? This is a keyboard. What is this? This is mouse. Right? And what is this box, big box? Everybody is saying this is a CPU, but it is not CPU. This box, this bada box is not a CPU. This is technically called as chassis box. This technically called as chassis box. Okay. So what this chassis box contain internally? See this green color. This green color ka chip. This is a motherboard. So inside motherboard, what is there? RAM is there. And CPU is there. CPU registers are there. And BIOS chip. See here down. BIOS chip. I will discuss what is BIOS chip and what is the use of this BIOS chip also. Just observe what present in the motherboard. Very important. Without knowing this, don't start programming. Any programming, not only C programming. You should know some concepts before starting any programming. And see here, this is hard disk, secondary device. Every application, every file will be stored in secondary memory in the hard disk. Okay, clear about this? So now I'm explicitly writing this motherboard ka diagram. I'm explicitly writing this motherboard ka diagram. See here. This is the motherboard ka diagram. And what motherboard contains? RAM, BIOS, CPU, CPU registers. Motherboard not only contain this much, motherboard maybe contain so many things, but this much is enough for our topic. Okay, consider this is your motherboard and this is your hard disk. Your new system ka hard disk, your new system ka motherboard. Now consider what your hard disk contains. Permanent permanent data. Yes or no? Whenever you bought your new system, is there any application present in a hard disk? Yes, definitely. OS is important, and some default application like Microsoft Store. So many default applications may be there, but I'm taking these two. Okay, na? These two are by default applications which are already installed in your device, in your hard disk. Okay, na? Okay, now tell me, you bought your new system. Now you are opening your new system. Why you bought your new system? Because you want to practice C programming. Now tell me, what is the first application you are going to install? Definitely some application which is used to write the programming concepts. Let's say Ubuntu application you are going to install. Let's say which application you install? Ubuntu application. Why Ubuntu application is used? It is used to write and execute the programs. Okay, now, and whenever you install Ubuntu, by default GCC application also installed with Ubuntu. What is GCC means? It's a compiler. So we have so many compilers are there like GCC, Turbo C. Why compiler? Compiler is used to convert high level to low level. So GCC is one of the compiler which supports Ubuntu. Okay. Okay. Now tell me how to open the system. Means how to turn on the system. On chassis box there is a power button. Consider this is the power button. Whenever you click on the power button of CPU, means chassis box, what happened immediately? Your system will open. Have you ever think how your system will open? Have you ever think how your system will open? What is the first program going to be executed whenever you power on your CPU? Whenever you power on your system, what is the first program going to be executed? Means BIOS program. Getting my point? What is the first program going to be executed? Who is activated immediately whenever you switch on your system? Means BIOS. This is the first program going to be executed, and this is a firmware. I will tell what is firmware and software. So this is a firmware, and this is going to be executed first. Sir, what is the responsibility of this BIOS program? The responsibility of this BIOS program is to check all the input output devices are properly connected or not. Means whenever you switch on the system, immediately BIOS will run and it will check all the input output devices like keyboard, monitor, mouse, and the RAM, this ROM, everything. It will check all the devices are properly working or not. If not working, then you will get BIOS error. Getting my point? So I'm writing about BIOS here clearly. So BIOS. It is a chip. BIOS is just like a chip where it is available on your motherboard. Okay. What is the full form of BIOS? Basic input slash output system. Basic input output system. And what is the responsibility of this BIOS? Say firmware, say firmware. So it's a firmware. It is used to check all the input and output devices are properly connected or not. If properly connected, then you can open your system simply. If not connected, then BIOS, if not connected properly, then you will get BIOS error. You will get BIOS error. Have you ever observed what is BIOS error? It is getting in some blue color, some BIOS error. So if you are getting BIOS error means your some of the input output devices are not properly connected. Getting my point? So whenever your power on your PC, the first program, immediately whenever switch on, immediately the BIOS will activate and that firmware will be running. That code, firmware is, that is a code which is directly integrated onto the hardware. That is a firmware. Okay. And BIOS will execute and it will check all the devices are properly connected or not. This much clear or not? So this is the first program. Whenever you click on power button, whenever you are trying to on your system, this will be run immediately. This BIOS will run immediately. Getting my point? Okay. Sir, after turning on, then what happened? Whenever you turn on your PC, the applications are going to load into the RAM from secondary memory. Secondary memory means HDD. This is treated as secondary memory. Okay. So first step, BIOS will run to check all the input output devices are properly connected or not. Okay. Now you may ask some questions, sir. How BIOS will check all the input output devices are properly connected or not? How it will check? Internally, it will send some signal to RAM, CPU, all the devices. If it is not get acknowledgement back, means if it is not getting reply back, then it is treated as some BIOS error. Getting my point? Maximum you will not get BIOS error. Okay, now in the rare case you will get BIOS error. Okay, step 1 clear or not? BIOS is clear. Okay, sir, after BIOS executed and all the input output devices are properly working, sir. Okay, my system open, sir. Yes, if all the input output devices are properly connected, there is no BIOS error, then your system will open. Sir, what happened immediately after my system opened? What happened means OS will load automatically. OS will load automatically from secondary memory to primary memory. OS will load automatically from secondary memory to primary memory. Okay, now who loads that OS? Who loads that OS? Loader. There is some concepts, grub loader and all, we'll discuss later. But as of now, think of it, what is your second step? First step is BIOS. Means steps whenever you turn on your system, the steps I am discussing. Whenever you turn on your system, first step is BIOS, second step is OS. This is the second step. OS will load. Sir, I don't want to load OS because I want to open Ubuntu and practice the programs, C programs. That's it, sir. I don't want OS, sir. Why to load OS? What is the use of OS? See, OS means operating system. It is also software. It is also an application. But see, without OS, any application, any application is not going to be executed. Without OS, any application is not going to be executed. If you want to use your Ubuntu, you should execute OS first. If you want to execute your Instagram, you should execute your OS first. Your WhatsApp, without OS, WhatsApp is also not executed. Sir, how, sir? Why? How to justify this question? See here, I will take one scenario. Consider I am in Hyderabad and my friend is in Bangalore. My friend is in Bangalore. Now, I want to send one photo of my selfie photo or anything to my friend. How to send? Which application I have to use? Maybe I will use WhatsApp. Consider there is some issue with WhatsApp application. Then consider WhatsApp application in my mobile is not working properly. Then you may use Instagram. Consider Instagram is also not working. Then you may use Facebook. If Facebook not working, then you may use another application also, Twitter. So many applications are there. But consider this time there is no internet. In my mobile, no internet. In this case, tell me, in this case, all the applications are working properly, but no internet. Now tell me, can I able to send the photo to my friend without internet? There is no network in my mobile. Can I send data? No, not possible. So what is the conclusion from this? Only having application is not enough. Only having WhatsApp is not enough. Only having Instagram is not enough. Only having Facebook is not enough. What is required? Services are required. Here, internet service is required for your applications. Otherwise, your applications will not work. So, applications important or services important? Sir, what is service? Here, internet is a service. Getting my point? Services are important. If you are not, if you are having some issue with one application, you may use other applications. But if you are not having service means internet means, then you cannot use any application. Who is providing service? Who is providing this internet service means operating system. OS is providing services to the application. Yes or no? So for every application, definitely some services are required. Not only internet service, so many services are there. All the services are provided by the OS. All the services are provided by the OS to the user applications. Getting my point? So, conclusion. Is any application will be running in the RAM without OS? Yes or no? Answer is no, not even single application, because for all the applications, what is required? Services are required. So who is providing services? OS is providing services. I hope you clear. Next step. Okay, so second step, OS is loaded. OS loaded, and now this first step and second step is not in your control. Means Whenever you switch on, automatically BIOS will execute and checking input output device is properly working or not, and immediately OS will be loaded. And login screen comes, means your user and password. Within fraction of seconds, these two steps are happen internally. And what is your third step? So your third step is you want to practice programming. That's why you click on Ubuntu application. Whenever you click on Ubuntu application, this Ubuntu application will be loaded into the RAM for execution. But before Ubuntu loaded, already in second step, whenever you power on the system, already OS is loaded into the RAM. You are thinking Ubuntu is the first application you are loading into the RAM. No, already whenever you turn on your system or mobile, the first application automatically loaded into the RAM is operating system to provide services to the applications. Getting my point? Okay, you open Ubuntu application. After opening Ubuntu application, what you will do? What you will do after opening Ubuntu application? What you will do? So see here, open Ubuntu, and what you will do, this is a terminal. So you are going to write programming here, like hash include. You are practicing the program now by opening Ubuntu application. Hash include stdio.h and int main function, something like int x equal to 5, y equal to 6, int result equal to x plus y, printf percentage d comma result. So this is the program you wrote. After writing this program, consider you open this program with the prog.c. This is your file name. In prog.c file, you wrote this program and you saved this. Now tell me where your prog.c will be saved. Where all permanent storage ka data will be stored. See here. Now your prog.c will be stored in secondary memory. Stored in secondary memory. Okay. See next. So who is going to be execute this x equal to 5, y equal to 6, result equal to x plus y, printing result? Who is going to be execute this? Definitely CPU is going to be execute this program. But CPU understand this program? No, CPU not understand this program. So what you have to do now? What you have to do now? You have to compile the program. Which compiler you have to use? GCC compiler. So after writing the program, in second step, you can first you have to write the program. This is step 1. In second step, you have to write GCC space prog.c, means you are going to compile your program. GCC is a compiler. It's a software which converts your high level to low level, means binary. So after second step, what happened? It will generate a dot out, which is binary format. So where this a dot out will be stored again? Again, it is going to be stored. See here. Again, this will be going to be stored in hard disk only, secondary memory. So a dot out will be stored. What this a dot out contains? Your program in binary format, x equal to 5, everything will be available in this a dot out, but in binary format. Who is going to be execute this? CPU will going to be execute this. See here. Okay. So now a dot out is generated. Now what you have to do? You have to submit this to whom? Who will execute? Your CPU will execute. How to give it to the CPU? There is some mechanism. You are not directly give it to the CPU. CPU take this a dot out, not like that. You have to load it into the RAM. How to load it into the RAM? By writing the command /a dot out. Where a dot out is present now? See here where a dot out is present here. from in the secondary memory, permanent storage. Now by writing the command /a.out, you are loading this a.out from secondary memory into RAM. So whenever you write /a.out, that will be loaded from secondary memory into RAM. Getting my point? That will be loaded from secondary memory to RAM. So now a.out is available here. See here in the diagram also. Whenever you hit /a.out, this a.out application, can I say a.out is an application? Yes, it is in a binary format. Can I say proc.c is application? No, proc.c is not application because proc.c contains your program, C program, high level language. A.out contains binary language. So this is treated as application. Getting my point? Can I say Ubuntu is a application? Yes, all these applications are in binary format. Okay, so how to load this? By writing /a.out. This a.out will be loaded into RAM for execution. Now a.out is active in RAM. So if the a.out is an application, if it is active in RAM, then this is treated as a process. What is a process? If the application currently active in RAM, that is treated as a process. Now CPU will fetch this step-by-step instruction. Getting my point? CPU will fetch step-by-step instruction. First, CPU will fetch x equal to 5. Yes or no? So what this a.out contains? See here. What this a.out contains? This a.out contains the same information. A.out contains x equal to 5, y equal to 6, result equal to x plus y, printing result. Everything is available in a.out. But which format? Binary format. Who converted this? This GCC compiler converted this. Okay, now after loading a.out into the RAM, now CPU will fetch data instruction by instruction. CPU will fetch, decode and execute. What is the first instruction? It will fetch x equal to 5. And whenever it fetch x equal to 5, CPU will assign the 5 value into x. Whenever it will fetch y equal to 6, CPU will assign that 6 value into y, like that. And CPU will add x plus y, like this. Getting my point? See the diagram. So CPU will fetch instruction by instruction and execute all the statements. And after that, finally, it produces the output. It will execute all the statements and it will produces the output. What is the output you will get here? X plus y, 5 plus 6, which is output is 11. Sir, okay, what is this CPU registers? CPU can also fetch not only from RAM, it can also fetch data from the CPU registers. Why, sir? Because if you fetch data from CPU registers, if CPU fetch data from CPU registers for execution, it is more faster. Getting my point? Instead of fetching data from RAM, if CPU fetch data from CPU registers, then the execution is very faster. But CPU registers are limited. Okay, no? But CPU registers are limited. We have to use these CPU registers effectively. Not every program need to use CPU registers because CPU registers are limited. Whenever it is very important, whenever you need faster access, faster execution, then only CPU registers will be used. We'll discuss this very clearly later, how to use CPU registers, how to not to use CPU registers and all. Okay, na? So here, this a.out will be loaded into the RAM. This is treated as process. And CPU will execute all the instructions and produces the output. Getting my point? So practically, I'm going to do this, whatever I did as of now. See here. So now, Consider this is my new system. Okay, now I'm going to open Ubuntu application. See here, I'm opening Ubuntu application for practice purpose. Now tell me where this Ubuntu application is available. See that motherboard diagram. Tell me where this Ubuntu application is available. In secondary memory. Whenever I click on this Ubuntu application, this is loaded into RAM, primary memory. Now it is treated as process. Now it is treated as process. So now I am writing some program like vi space xyz.c. So I'm writing C program. So your file extension should be .c extension, because every information having some extension. Executable file .exe extension. So this is .c extension. If you consider music mp3 .mp3 extension, some images .jpg extension. So every information having some extensions. So that's why open it with .c extension. Vi means, why I'm writing vi means to open some editor. So vi editor. So some editor will open. In that editor only I'm going to write the program. Enter. So now I'm writing the program. Hash include stdio.h int main function int x equal to 5 comma y equal to 6 int sum equal to x plus y. Printf sum equal to %d slash n comma sum. So I wrote program. After writing the program, what I have to do? I have to save this. How to save this? Escape shift colon WQ. WQ means save and quit. Now my prog.c will be saved in secondary memory. See here prog.c. See here prog.c will be saved in secondary memory. Okay. Okay. Now what I have to do? To whom I have to submit this program? Whatever the code I wrote, to whom I have to submit this program, to whom I have to submit? To the CPU. But CPU understand this. Whatever the code I wrote, is CPU understand this? This is a high level language. CPU will not understand. Then what I have to do? You have to compile this gcc space xyz.c. Getting my point? What this compiler will do? What this compiler will do? So let me zoom it. What is GCC? It's a compiler. It converts high level to low level language. Hit enter. Now compilation done. What this compiler will do? It generate the application a.out file. How to check it? Give the ls command. So here you can observe here a.out, third row, right? Now what I have to do? Now I want to execute. Who will execute? CPU. From where CPU will fetch data? From RAM. It is fetching the data from RAM means you have to load it into the RAM. You have to load your executable file, a.out file into the RAM. How to load it? By writing the command ./a.out. Now this a.out is present in hard disk secondary memory. Now it is loading from secondary memory into RAM, and the CPU will fetch data from the RAM and it will produce as the output. Enter. Getting my point? So here can observe the output sum equal to 11. Okay. I hope you got answers for all the questions. See here. So let me check, is there anything missing here? So what is programming language? Told programming language is a high level language which converts, sorry, programming language is a high level language which is used to communicate with the system, right? So why to communicate with the system, sir? What is the need of programming language? Why to communicate with the system means to perform the complex tasks. Next, what is compiler? It's a software which converts high level language into low level language. Means machine understandable format into machine understandable format. It is going to be convert. Which compiler we took? Here we took the example of GCC compiler, right? Next, what is BIOS? I told the BIOS. BIOS, it's a firmware. It's a firmware. And what is the responsibility of this BIOS? This is the first program which is going to be executed immediately after turning on your PC. And what is the responsibility of this BIOS program? It will check the system integrity. Means system integrity check means it will check all the input output devices are properly working or not. And this is what is secondary memory. So secondary memory means ROM, HDD, permanent storage. All the applications and files are stored in secondary memory, ROM only. And what is primary memory? Primary memory means RAM. What is primary memory? Primary memory means RAM. There are so many names to this primary memory. You can say this primary memory as RAM also. And you can say this memory as program memory. And you can say this as main memory also. These are the various names to the RAM. RAM is treated as primary memory, program memory, main memory, and volatile memory. But the secondary memory is treated as non-volatile memory. What is volatile memory? What is non-volatile memory? Volatile memory means the contents in the memory will be deleted if power is off. Getting my point? Volatile memory means if power is switch off, if you switch off your system, then all the contents available in primary memory RAM will be deleted. That is the meaning of volatile memory. What is the meaning of non-volatile memory? Secondary memory. HDD is the example for non-volatile memory. Even though if you turn off your PC, the data will be not erased. But if you turn off your PC, the data will be erased from the RAM. This is volatile memory. Next, what is application? Application means, what is application? So application is nothing but executable file. And these applications are in binary format. And these applications are present in secondary memory. Okay, now then what is process? If application loaded into the RAM, if application loaded into the RAM from secondary memory to primary memory, if the application active in RAM, then this is treated as process. And what is OS? OS is also a software. This is the first program loading into your RAM immediately after switching on your PC. And what is the responsibility of OS? Without OS, you can't imagine any application working. Yes or no? Because OS is providing the services. If you want to run any application, for that application, what is required? Services are required. So who is providing that services? Operating system is providing that services. And what is CPU? CPU only executing your all instructions. Yes or no? So CPU understands only binary language. That's why compiler is converting the high level language into binary language. And CPU is fetching data from RAM and executing all the instructions and producing the output. CPU may fetch the data from registers also. If it is fetching the data from register, then your execution will be very faster. But registers are limited. Okay, na? So you are not always going to use the CPU registers for execution. That we'll discuss later. And what is the difference between firmware and software? Firmware means I will tell here what is firmware and software, and we'll leave the class after this. Okay. So now, what is the difference between firmware and software? See here, consider this is the motherboard, and consider this is hard disk. And what hard disk contains? All the application, let's say WhatsApp, Facebook, Instagram. These are the applications. And motherboard, inside this there is a chip, that is BIOS chip, and it is having some program internally which is directly embedded onto the hardware. This is firmware. And here, see, observe here in a hard disk, this WhatsApp, Facebook, Instagram, all these are applications. Can I say all these are files? Yes. So all these applications are treated as softwares. This WhatsApp contains instructions, Facebook contains instructions, Instagram contains instructions, but the instructions are in file format. But here, by us, the instructions are directly written onto the board. Then this is treated as firmware. If the instructions are written onto the file, if instructions are written into the file, like applications like WhatsApp, Facebook, Instagram, whatever. So all these are treated as softwares. So what is firmware? Firmware means if instructions are directly embedded into the hardware chip, directly embedded into the hardware chip, then that is treated as firmware, which is BIOS. Okay. I hope you are clear with this lecture. Thank you.